Have you ever wondered what the difference between IPv4 and IPv6 is? Well, to understand that, first we must grasp what an IP address is. Picture it as the street address for your device on the vast landscape of the internet. It's a unique string of numbers and letters that allows your device to communicate with others, sending and receiving information. Now, there are two versions of IP addresses that rule the internet: IPv4 and IPv6. Imagine them as two different languages, each with its own unique structure and capacity to express information. The IPv4, or Internet Protocol version 4, has been around since the dawn of the internet, while IPv6, Internet Protocol version 6, is the new kid on the block, introduced to deal with the limitations of its predecessor. Now you might be thinking, why do we have two versions? Good question, let's delve into that. First, we need to understand IPv4, the fourth version of Internet Protocol. Let's dive right in. IPv4, or Internet Protocol version 4, is essentially the backbone of our internet. It's the technology that lets your device, whether it's a smartphone, laptop, or smart fridge, communicate with other devices around the world. Now let's break down an IPv4 address. An IPv4 address is made up of 32 bits, divided into 4 octets or sections. Each octet contains 8 bits, giving us a range of 0 to 255 in each section. So an IPv4 address might look something like 192.0.2.255. The way we write these addresses is in decimal form, but under the hood, they're actually binary numbers. That's right, your device sees an IPv4 address as a string of ones and zeros. So 192.0.2.255 would actually look like 11,000,000,000,000,000,000,000,000,000,000,000,000,000,000 111111111 to your device. Now here's where we run into a snag with IPv4. Because it uses 32 bits, the maximum number of unique addresses it can provide is around 4.3 billion. Now that might sound like a lot, but when you consider the number of devices in the world today, it's actually not enough. Each device needs its own unique IP address to communicate on the internet, and we're quickly running out. This limitation has led to some clever workarounds like Network Address Translation, or NAT, which lets multiple devices share a single public IP address. But even with these workarounds, the reality is that we're simply outgrowing IPv4. IPv4 has served us well, but with the growth of the internet, a new solution had to be found. Enter IPv6, the sixth version of Internet Protocol. This is the new kid on the block, designed to address the limitations of its predecessor, IPv4. Notably, it's here to tackle the looming threat of IP address exhaustion. We're running out of unique identifiers for all our devices, and IPv6 is our lifeline. But what makes IPv6 so special? Let's take a closer look at its structure. Unlike the 32-bit length of IPv4 addresses, IPv6 addresses are a whopping 128 bits long. That's 4 times the size of an IPv4 address. And with great size comes great capacity. This allows for a staggering amount of unique addresses. We're talking about a number so large it's practically impossible to grasp. An IPv6 address isn't just bigger, it's also structured differently. It's made up of 8 groups of 4 hexadecimal digits. This might sound complicated, but it allows for greater flexibility and easier management. To make things even more efficient, IPv6 also introduces some shorthand methods to compress these addresses. But wait, there's more. IPv6 doesn't just give us more addresses. It also improves upon the functionality of IPv4. For instance, it includes built-in support for IPsec, a protocol suite that encrypts and authenticates IP packets. This makes our online communications more secure. IPv6 also streamlines data flow with features like header simplification and flow labeling. In the IPv4 world, routers had to spend time and processing power to fragment packets. But in the IPv6 realm, this responsibility is shifted to the sender, resulting in more efficient routing and packet processing. And let's not forget about multicasting, something that IPv4 does support, but not as efficiently. Multicasting allows a single packet to be delivered to multiple destinations, and it's an integral part of IPv6's design. So IPv6 seems to be the solution to our problems, right? But how do these two versions compare? Well, stay tuned as we delve deeper into the differences between IPv4 and IPv6 in the next segment. Now, let's get to the heart of the matter, the key differences between IPv4 and IPv6. Firstly, let's talk about the elephant in the room, the address length. IPv4 addresses are 32 bits long, while IPv6 addresses are a whopping 128 bits. This means that IPv6 has a significantly larger address space than IPv4. In fact, the number of unique addresses that IPv6 can support is so vast, it's almost unimaginable. For perspective, while IPv4 can support over 4 billion unique addresses, IPv6 can support a staggering 340 undecillion. That's a number with 36 zeros. But it's not just about the numbers. The structure of the addresses themselves is also different. An IPv4 address is typically presented as 4 sets of numbers, each ranging from 0 to 255, separated by periods. For example, 192.0.2.0. On the other hand, an IPv6 address is presented as 8 sets of 4 hexadecimal digits, separated by colons. For example, 2001, 0db8, 85a3, 0000, 0000, 8a2e, 0370, 7334. This brings us to another key difference, the use of hexadecimal in IPv6. While IPv4 uses decimal notation, IPv6 utilizes hexadecimal. This allows for a much larger number of unique addresses and also makes the addresses more compact. However, it can also make them a bit more challenging to read and write. The way these protocols handle data packets is also quite distinct. IPv4 uses both fragmentation and checksum fields. This means IPv4 has the ability to fragment packets, but it also needs to recompute the header checksum at each router hop, which can slow things down. On the other hand, IPv6 has dropped these fields, speeding up router processing. In terms of security, IPv6 has a slight edge over IPv4. IPv6 was designed with security in mind and includes built-in support for IPsec, Internet Protocol Security. While IPsec can also be used with IPv4, it's not a fundamental part of the protocol like it is with IPv6. Finally, let's talk about configuration. IPv4 typically requires manual configuration or a DHCP server, which can be a bit of a hassle. IPv6, however, has a feature called Stateless Address Auto Configuration, SLAAC, which allows devices to configure themselves automatically. This can be a real time saver in large networks. As you can see, while IPv4 and IPv6 serve the same basic purpose, they do so in very different ways. So, what does all this mean for the future of the internet? Well, the transition from IPv4 to IPv6 is more than just a technological upgrade. It's a paradigm shift that will redefine how we interact with the digital world. With the surge in smart devices, Internet of Things, and the impending wave of 5G, an address space expansion was inevitable. IPv6, with its seemingly infinite address capacity, is the answer to that demand. However, the transition isn't as smooth as flipping a switch. There are challenges to overcome. One key hurdle is the lack of IPv6 compatibility in older devices and systems. Retrofitting these systems can be costly and time-consuming. Moreover, training IT professionals to manage and troubleshoot IPv6 networks is another task that needs addressing. But let's not lose sight of the bigger picture. IPv6 is more than just a solution to the address space issue. It's a platform for innovation. Its built-in features like stateless address auto-configuration and network layer security can pave the way for smarter, safer internet practices. It can create a more seamless user experience with improved performance and connectivity. As of now, the transition to IPv6 is happening, but at a slower pace than anticipated. According to the Google IPv6 statistics, as of October 2023, just over 30% of Google users have access to IPv6. It's a steady climb, but there's still a long way to go. But remember, the internet is a dynamic entity, always evolving. And as we move forward, IPv6 is not just a possibility, but a necessity. It's the backbone of a future where everything is interconnected, where the line between the physical and digital world blurs. The internet is constantly evolving, and as we move forward, IPv6 will play an increasingly important role. So, next time you're browsing, remember, there's a lot going on behind the scenes.